revision for the exam. Okay. The exam revision that I provide you is a little cryptic. Contained within it is all the things you need. Okay, but I'm not going to spell out and say, learn this. I'm going to give you things that I want you to know, and if you know those things, you will do well. Okay? So I can't just show you the exam, but I can certainly give you some guidance as to the direction the exam will go. Okay. So the revision advice, the first note I note up here is that this is and may not be the only topics which will be examined. Okay, and I always put that down, although I've already told you that most of what you'll need is here. Okay, I still require you to look at your course notes, handouts, and in-class exercises. But if you study your study your assignment 1, study your assignment 2, which was very complex in terms of the written report, build up on the fact that you've developed quite a significant portfolio of knowledge, and incorporate that into the coursework, I think you'll have more than enough in terms of resources to achieve a very good result for this as well. Okay, but that's my little disclaimer. I've got another disclaimer here, and that is that this advice only relates to the main exam, the one that will be held in a couple of weeks. If for any reason you're not able to sit the main exam and you have to sit a deferred exam, which will happen in a week, the exam structure, the questions and the weighting will be different. Okay? So, if you're in a requirement to sit the DE, you must review all the topics noted here and review other methodology topics and course notes. Okay? So, obviously the most important thing would be to sit the main exam because you're going to have the most amount of guidance in that regard. In regards to the deferred exam, I'm not going to be around, so I'm not going to be able to give you any help if you're having to sit the deferred exam. Okay, I'm going to be out of the country. Alright, so take on board what we provide. Okay, so let's start off with the beginnings. We began with this thing called building design. And the first weeks or couple of days in the first session, we talked about all the things we needed to get started with to get our building up and running. We couldn't just go out and build anything anywhere. We had to have some guidance notes. We had to have some direction that we had to follow in terms of what we could build. And there were a whole series of things that come in. For those of you madly writing down, good, you should. The other side of it too is these notes will be online about lunchtime as well. So if you want to get copies of these, you can download them after lunch. Site factors. Okay, so what were the site factors which could influence a building design? Well, let's look at some of them. Landslide. How does landslide affect design? You tell me.
The section where the footing goes and all of that.
Okay, so one of the possibilities is the placement of the building on the site based on the condition of the land. Yep. Anything else?
Construction method.
Construction method. Okay, so we might choose a different style of building based on the amount of slab. Some sites may not be suitable to concrete slab construction and more suited to timber floor construction. Okay, so landslide can impact on ours. We might also potentially offer us things like views. We might design to capture the views or the breezes or something else. Land size. Now, all of you have had a variety of different lot sizes, from 10 metres wide to 20 metres wide. And we've all discovered it, and you've looked at, realised that your house is constrained within that size of the lot, based on setbacks and overall building dimensions. Okay? So sometimes you have to choose a building that fits the land. Soil quality, of course, that's pretty big, isn't it? That played up a big part of what we talked about, soil classification. You're all given a soil classification to work with. And that changes the size of our footings, the size of the base of the building, effectively. If we have an overall size of the lot, we have to, our soil quality may impact on how we affect drainage around the site, those sorts of factors. And then vegetation influences on soils as well. That's another factor, things like removal of trees. We didn't really cover too much of that in this subject. A few other little external factors like easements. Of course, easements are contained within a lot and restrict what can be built on the lot. Okay? Luckily, all our sites didn't have easements on our assignment, so that made it easier for us. All the services that we needed to connect with were, of course, located around the front of the allotment, or in some cases on the side. The covenants. Okay, the developer covenants is one of the areas most groups probably could have spent more time looking at, because a couple of times I saw some methodologies of building, like cladding and things, that may or may not be suited to the covenant of that development. So be aware that the covenants are these things that control what types of look of your building, the effect of your building. You saw covenants related to, say, location of the garage, the frontage of the property. We saw covenants related to the front porch, and how the roof line had to extend out beyond a certain part from the building. A lot of those sorts of things came in as part of design characteristics. Okay, so they affect our building. And then we've got the planning controls, which are the ones that we discovered. If you looked at the planning scheme, you would have discovered that the area that we were reviewing had an issue in relation to fire or bushfire management, which of course was an old layering of it, and I think there was another matter that related to it as well. It's also part of a Queensland development approval as well, so it wasn't planning by way of local council, it was managed by the state government, which is quite different. So governments and councils get involved in all the planning controls. Okay, so these factors, these are external factors which are going to influence, and site-based factors which are going to influence what we can build. Okay, what are the external resources? Okay, so let's have a think about those. What are some of the external resources we could take advantage of to find out more about our site? RP data is an external resource. It can tell us a little bit about our site. Yeah, what else? Queensland Globe. Council websites, planning, council planning. Yeah. Yep. Somewhat, but not so much in somewhat in design. Okay. If you're not sure what they are, start investigating. What external suppliers? Well, RP Data, Queensland Government, local council, private providers. Okay, things like when we're talking about soil tests, engineering firms, people that do soil analysis. Okay, so they're external resources, and they're the sort of people we can get information about. I mean, one of the things we talked about was that you could, in fact, do a soil analysis by simply walking up to the site, scratching around the outside of the concrete slab if there's one there on an adjoining lot, and check the depth. And if there's 2 or 3 houses along that section of road and they all have the same depth footing, chances are your site may well be in that range. I'm not saying it is, but it may be. So just by investigating what construction's going on, look at a frame and see what sort of bracing is incorporated into it. Could give you an idea in terms of wind load requirements. So contractors, builders, people working around the site, could all provide advice. You get salespeople, you know. What major construction standards apply to building design? Oh, there's so many, wasn't there? But there was a key number. What's the major construction standards applying to building design? What were they? Do you remember all the different numbers and their names? Sorry? Yes, that's a good one. 2870, that's a starting point. AS 2870, which related to? Oh, hang on, we'll go back to 2870. What do they relate to? Slabs and soils. 4855. Design for wind actions. What's the big one that we spent lots of time looking at? 1684, residential timber frame construction. Okay, so so be aware that those standards exist. Okay, and perhaps maybe know a little bit about them. What are the two main areas of knowledge we need to know before we can design our building? We talked about this. Before we can actually build, before we can even come up with a plan, we need to know about these two key factors.
Like the site?
It's related to the site, but it controls what we can construct in terms of design. We're talking about soil. That's exactly right. Soil is one of them. What's the other one? Wind. Wind loads and soil class. If we don't know those two, we can't go anywhere forward. Okay, we can design the best looking house for the covenant, we can design the best looking house for the lot, we can do all these other things, but at the end of the day, if we haven't designed the right footings and we haven't created a resistance load within the building, it's not going to stand upright, it's going to fall over. So wind loads and soil class are the two key elements that we need to be knowledgeable of. And so in knowing that, you need to know the process of how we undertake those things. How do we undertake a soil test? How do we undertake a wind load analysis? Okay? Alright, let's look at some of the materials that go into our buildings. So now we're talking about selection of materials. And one point we looked at was timber. We looked at timber grading. We said there was two ways we could grade our timber. One way is we can do it by way of H grade, which is our hazard grades. Do you remember the different numbers of the H grade, where they go from? H what to H what? 1 to 6, yes. And then the F grade was F, about F2, F3 to F34, all related to function or forces of resistance. Alright. Then we've got slab and timber floor construction terminology and methodology. My goodness, there was a lot in that, wasn't there? Okay, because we talked about slab design and we talked about building timber flooring. Okay, so the key sort of points for this subject has always been terminology as being an important requirement, so knowing the terminology in our building design. The methodology, which is the methodology of assembly. And so those two factors, really, if you can look at a diagram and be able to detail it, that's kind of where we want you to be. So we'll be able to detail up it. If I gave you a diagram of a part of a building, what I'd love you to be able to do is go, right, that's it, here it is. I can detail that up, and if I had to detail the methodology of building that part of the building, I could step point, dot, 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 and get my answers. Same with framing and roofing. Terminology and methodology also can be incorporated into that. So roof design, frame design, what happens, what goes up in what order. Those answers, often the wall framing is all in your assignments, so you've already got that. Slab and timber floor construction, well, the slab construction is all in your assignment too, as well. But make sure you look at all the other options. Okay, so another part is review your assignment drawings. A lot of what we've given you is so that you can do revision. These assessments is a part of knowing the information. So review your assignment drawings. Learn about your site plan, okay? Find out what was missing on the site plan or what detail you should have added to the site plan. Look at your floor plans. If there was any commentary about that, whether you needed to make some amendments, have a look at that. Cross-sectional drawings. They're very good because a cross-sectional drawing should be fully detailing out all the elements that you would have seen. And landscape drawings in regards to the way that the harder soft landscaping is developed around the site. Okay, so just have a look through, review your assignment drawings, have a chat about those, tell me what sort of things that perhaps you need to review or improve, and go from there. So let's start the build. Okay, so that was all preamble before construction starts. Now we start. Okay, so the site will impact on our building design. As I mentioned before, if we have a flat block, we could build a concrete floor or we could build a raised timber floor, doesn't really matter. If we're on a sloping site, depending on the degree of slope, we could build a stepped concrete slab, or more preferably, we build a raised platform. So Topography will play a part, landslide. Any retaining works, if there's retaining walls necessary, they may need to be incorporated into the build as well. So, processes of what's important about retaining walls could be noted. The effects of adding fill to a site classification. We all looked at that, and a few of you commented on building up the land and adding some fill, and then you had to go and check AS, 2870, and check to see whether or not the fill was needing to be controlled or uncontrolled based on depth of fill. And we talked about that in class. So we start cutting the site and we create a nice flat platform. So how do we do that? Ways to create the site pad. How do we achieve the different options? So we have a cut method, we have a fill method, and we have a cut and fill. 3 different ways we can develop our site. Site works. What happens at the start to prepare for the house? What do we do before we can actually start? We've created a flat platform. What do we have to do now? What do we have to find? Well, we have to find where the house is going to go on the block. So we have to do a survey to establish the location of the proposed building. And once we've done the survey, then we can use that survey information to be able to tell us where all our services, our in-ground services are and how they connect. And as you've now discovered with that part of the assignment related to services and the drawings, that we need a series of documents that help us explain where those service connection points are and learn from that to then where we then connect to from our building to those points. So the main service connection points, of course, would be sewer, electricity, telecommunications as a junction point, and then externally we then send water out of the building either to the sewage system or the street drainage as a secondary system. And so I put a separate section there, in-ground services, but then put dash drainage strategies for water and sewer. Because as one of the things we both checked when and I looked at was making sure that your sewer and your drainage went downhill. And often everybody pretty well covered that well. I don't think anybody sent any of their water pipes uphill, which was good. But they're the things you need to be conscious of. If you're building and the land drops away from the road and you can't get your water pipes for the rainwater drainage to the road, you're going to have to go and find a place at the back of the lot that you can drain to. And that may well be a pipe, and if there's a pipe for services, ultimately then you're going to have an easement. Okay? So remember the whole in-ground services section. Talk about that. If you remember that and you're comfortable with all the different types of in-ground services and how they go in and capping the tops of your pipes and making sure that they're all coming up out of the ground. Some of you are very detailed in your reports in terms of describing the pipe and the pipe manufacturer and the way you glue the pipes together and the downfall and sitting on beds of sand and all that great stuff. So there's lots of interesting knowledge there that you can add with. Determine your footings. So we need soil, we need wind, we need to calculate our footing. There's really only 3 concrete types: isolated, which are independent pads and piers; continuous footing, which is generally a strip footing running around the perimeter; and then the integrated footing, which would be your raft slab, your waffle slab, your split slab design. Okay, one thing I do like to ask you to do is remember the stop points. Okay, make sure that you remember the stop points. What point do we have to stop before we have to get an inspection done? Okay, quite often when there's a question based around methodology of building, and let's say it's slab related, one of the things invariably people forget is the stop points along the way. So they just go on, excavate site, undertake survey, start putting in-ground services in, start formworking up, put the deck-proof membrane, and then pour the concrete. And then they go, well, you've missed 2 parts. You've missed the plumbing inspection, you've missed a steel inspection. So remember the inspection points. Basement design and construction. We covered that for a little bit We talked about basements and how big houses now are more and more incorporating basements. And we talked about how we can build them by way of retaining walls built into the basement. So the basement wall becomes a retaining wall, of which we have to waterproof. We also talked about how the basement itself could have a suspended roof, and that suspended concrete roof could be either a traditional form roof or it could be a post-tensioned roof. Okay, so have a little review of basement design and see if there's anything there that you haven't quite remembered. Of course, flooring design, any of these sorts of diagrams turn up in an assessment. Of course, you should be able to understand the differences between the two. One of which, at the top, of course, is a concrete slab, in which case, what type of slab is it? Tells us on this drawing. It's a stiffened raft. Suitable for what type of soils? Pretty much all. Yeah. So what about that to a waffle pot? Is a waffle pot also equally useful for every soil type? No. So if you were given a question that asked you about, you've got a soil type of H2, could you and can you build a waffle pot? What would your answer be? No, you can't. That's right. Okay. So being able to be aware of what type of slab can be used where, and the design of the slab is an important part of your review as well. So there are three types. The raft slab, so understand and be able to both identify and detail up the process of constructing the raft slab, be able to detail, identify and discuss the process of constructing a waffle slab, and a timber floored system, raised timber flooring system, which invariably would be like the bottom drawing there, which is your isolated piers, perimeter base wall, and then bearers and joists on top. Okay, so one of your revision points is going to be methodology of constructing those three things. Wall framing and roof framing. Always, again, we keep coming back to terminology, methodology, and process. Okay, so if you were given a wall frame, it's a diagram, could you detail the diagram? If you were given a roof frame, could you detail the diagram? If you were asked to discuss the order of assembly of a roof frame, would you know how to do a hip end? Would you know how to do a gable end? Would you know how to do a Dutch hip? If you are going to do wall framing and required to then talk about perhaps bracing elements with the wall framing, would you know where those bracing elements go and where traditionally would they be located and how would they be put in and what type of material? Okay, so that's the terminology, the methodology, and then behind that is the process. The process, of course, could well be a question we've asked in the past. Tell me how you assemble a wall frame in preparation for a roof frame. You go, or roof cladding on top. So you'd have to talk about setting out on the slab, standing the frame members, talk about plumbing and bracing, talk about temporary bracing, needing to be 60% of the main brace, talking about the permanent bracing then being installed, etc. So that's the sort of things in terms of the process. So we're not going to be asking you to do any engineering calculations. So that wind load analysis that we saw back, I think in the second session of notes, where we had to do a detailed COS roof pitch times half wall times roof plus, etc. You're not going to get a calculation like that. Okay? We just want you to know the fundamentals of assembly and process of putting things together. Wind loads and bracing. So, steps to undertake a wind load analysis. We've learned from assignment 1, it's a 5-step process. Okay? Most people do remember the first 4 steps and forget the 5th step, which is the thing where you bring all the other steps together and give us a result. Okay? So remember the 5-step process. So that's pretty straightforward. You've all done that in assignment 1, you should all know that. How is bracing determined? Well, that's that extra bit that we've just talked about. So, not so much how you do it, but know the process involved. Okay, you have to know the wind load, you have to know the size of the building, you have to know what order or what amount of the building is going to be the deepest end facing the worst amount of wind, etc. So talk about that process. Okay, there's a slide that in I think weeks in session 7 or session 8 that does detail that all on one slide. So we'll look at that. And then what forms of bracing exist in framing? Of course, there's really quite a number. If you go to 8.18 of the section 16 or AS 1684, you'll find a whole lot of them. And each one has a different function. Some provide more bracing resistance than others. So just be aware of what some of those are. Cladding to building. Okay, so again, quite a lot of the assignment 2 was based around cladding. We did wall cladding and we did roof cladding. So your assignment 2 really covers the cladding area. Things like installation methods for windows and doors, all that should have been covered in your assignment. Types of windows and doors also was covered in your assignment. So that information, you can see a lot of the information we've given you, we've encouraged you to learn, so it's there. It's just a matter of then going back now and reading your assignment. You made us read 150-page assignments, we might as well make you read them as well. So get back in and read your assignments again. Okay? Awesome. External cladding, same thing. Walls, roof materials, drainage requirements, eaves, fascias, gutters. External wall materials, bricks, timber, metal, ply, foam, rendered brick. Okay, we've given you a few extra ones than what you would have done for your assignment. But you've already dealt with some of them, it's only adding a few little extra bits in. Okay? And in that sense, what we're talking about is what types of cladding there are, wall cladding and roof cladding, but then also how do we fix those. Okay, so assignment 2 covers a few types and how to fix those types. You really need to pick up on perhaps ply, foam, rendered brick maybe, although some covered rendered brick in their assignments. So just a little bit of revision from that reviewing of your assignment 2. Internal cladding was also part of your assignment 2. So again, that should be there, should be answered by now. You should know about plasterboard and fixing of plasterboard. 2 extra things like timber paneling and fibrous cement sheeting, those sort of things are extras. I don't really worry too much about that, but if you're going to be talking about plasterboard, you should know wall fixing, roof fixing, cornices, the finishing, the mouldings, the architraves, the skirting boards and those sorts of things. All those elements should come into your knowledge field. Okay. Internal fit out. What activities occur? So the internal fit out is that bit where we're doing kitchens and bathrooms and electrical and plumbing installation. Okay? So the internal fit out is all those things that happen once the building is enclosed. The weather is now outside and locked away, and we can start putting things inside without fear of water getting in and damaging it. So there's all the internal electrical wiring through the framing, the walls, the plumbing roughing through the building. Okay, again, a lot of that should have been dealt with through your second assignment. Okay. Electrical plans and plumbing plans. And I'll just bring those two in because remember that we had that discussion about the electrical layout, about walking through a building and walking back out and making sure that the electrical layout works. Okay, so you should be able to look at an electrical plan and be able to understand it. I'm not saying it's going to be an exam question, but it's something you still need to be comfortable knowing. The last little bit is finishing off. Switches, taps, hot water services, electrical appliances, all of which, again, assignment 2. They're all in there. Kitchens in assignment 2, bathrooms in assignment 2. Things like stairs are not, because nobody did a 2-storey house. So if you haven't briefly gone and looked at stairs recently, remember that little discussion about stair design and orientation of stairs, might be worth having a look at. External drainage generally comes in at the end as well. Remember that's sort of like linkage to landscaping, that external drainage. So that's why that one's popped up again. Hot water services. Of course, there are 3 different types, or 4 different types. You've got the big electric, you've got gas, you've got Instamatic, you've got solar. There's 4 different types of hot water services. Consider design strategies. How do all those sort of different parts, kitchens, bathrooms, how do we design a kitchen? How do we design a bathroom to work efficiently? How do we design a hot water service to work efficiently? Okay? And last but not least, landscaping. Okay? I can tell you now, you're not going to spend much time dealing with landscaping. I won't be putting a whole series of genus-species plants up there and asking you to tell me what they are. That would be a bit mean. But there may be some notes in relation to hardscaping and softscaping or something of that nature. Okay? Alright. We also, during the course of this period and through your second assignment, we helped you out with some drawings. I would like to think now, judging by the quality of the majority of the drawings that came through, that most of you now should be able to read a set of plans. Someone handed you a set of construction drawings, you should be able to now look at them, work out size of rooms, work out placement of services within those kitchens and bathrooms, like where are the sinks, where are the taps, where are the appliances. You should also be able to look at various elements like a drawing and go, oh, I know exactly what that drawing is telling me because I understand all the elements that are in that drawing. Okay? So, I've given you 3 dot points, site plans. Okay? So if a site plan turns up on in your exam, you should be able to go, what's missing? Or what should be added into this? If it's a wall framing drawing, well, you should be able to identify everything that's in that wall frame. You should be able to look at it and go, oh, yeah, I know all those elements. That's this, and this. If it's a roof framing, then you may have an end, type of end, a hip end, a Dutch hip end, a gable end, a skillion end, who knows. And you might need to be able to detail that or explain how it was put together or something of that nature. Nobody's going to ask you to do a truss layout plan. Okay, so ignore that. Don't sit there and spend weeks trying to work out the next 2 weeks which truss goes in which order and then have to draw it all up. Okay? You need to know the order of assembly, but you don't need to actually have to draw it all up. Okay? And the last one, of course, is cross-sectional, because every now and then I throw a cross-sectional drawing into an exam and just ask you to go and label everything you can see in a cross-section, and you'd be amazed just how much turns up in those cross-sectional drawings. So just, again, do all that. Guess what? You've got all that. Again, it's all your drawings. Okay? Just a comment too, while I thought about it just then, just little pings popped in my head. The groups in the assignments, the groups that actually adopted or incorporated some of their drawings that they spent time and effort on creating, you cut them and put pieces of those drawings into their assignment. Well done, great work. That was an awesome use of the resources that you were developing. Always think about how those resources that you're creating can be used for more than just the one function. Okay, I saw models, photographs of models being put into the assignments. Brilliant. That was utilising a resource that you'd created. I saw lots of individual drawings that were added into the assignment. Well done. So there, just think about that for future. That's not for this subject, that's for all future subjects. If you're asked to do different things, see how each piece could be perhaps brought together. Okay? That was just a comment because one of the things I think I probably was a little bit frustrated it's the only thing I was probably a little bit frustrated about was how the 4 parts of the assignment sort of didn't all gel in some cases. Sometimes they did, sometimes they didn't. One of the things Lynn and I did, just so you know, is how we marked your cross-sectional drawing was we laid your cross-sectional drawing out on the table. We then grabbed your model. We sat your model directly on top of the cross-sectional drawing and checked for a correlation to make sure they were accurately matched up. So they're the sort of things that we were doing, checking to make sure that if you had a 1 to 20 scale of this and a 1 to 20 scale of that, they should be the same. So those interrelationships of the various elements is where those groups that did that were the ones that were really getting up those high marks. All right. So here's the crux of it all. The exam. Okay, got 9 questions. Okay, the questions range from 5 marks to 20 marks. So there's no mega question in there that if you stuff up, you're going to fail. Okay? It's 9 very small, chunky questions of all different things, and each one is going to give you an opportunity to tell what you know. Okay? And starting with that, there are two drawing tasks, or two construction drawing related questions. So they're going to be questions that require part of a building to be detailed and correct terminology use. Okay, if we're going to do terminology, we're going to have to ask you if you know the terminology. So we're going to put some questions in that are going to ask you to detail up something of the building. Okay, if I go back a slide, okay, it could be something like that. Either one of those two detailed drawings pop up, and you have to fully explain those. Okay, one's a cross section, one's a roof design. Okay, that's the sort of thing. You're going to get a diagram, you have to detail up the diagram or explain the diagram. Okay, so that's about reading, learning, knowing drawings. Okay, there are two questions with sub-questions. In other words, they're looking at testing knowledge acquired in the course notes and our in-class discussions on site construction methodology. So in other words, it's probably going to be a question that talks about what is this, why do we use it, how do we assemble it. Okay? Something like that. There'll be single topic written question. So there'll be 3 specific topics. We can pick anything. Okay? So they could be related to design matters. It could be related to fit out. It could be related to construction. It could be related to services. It could be related to footing design. It could be related to framing. It could be related to bathroom layout. It could be related to landscape. Okay, these are individual specific questions. Each one of those, I think from memory, is about 10 marks each. So if you know 2 of the 3, brilliant. If you only know 1 of the 3, fudge it, fake it, write whatever you can. Alright, there's one drawing question. So we've got drawing interpretations and drawing understanding, but then there's one that you actually have to do some drawing in. Okay, so you need to bring some drawing equipment with you. Pencils, rubber, ruler, something like that. And you'll be required to produce a drawing of a part of a building structure and indeed doing that, detailing the order of assembly of that structure. Okay, so don't worry, it's not going to be I'm not going to ask you to draw an entire house frame. I'll be asking you to draw part of a house frame. Or I'll be asking you to draw part of a roof. Or I'll be asking you to draw some cladding. Or I'll be asking you to draw a footing. Or I'll be asking you to draw some sort of fit out or fixture. Okay, so it's going to be quite specific about what it is. Okay, and when you draw it, here's a guide. When you do have to draw it, okay, you're not required to draw the whole house. Have we all got that? You just need to demonstrate what it is you're trying to draw, what you're trying to create. Okay, so it's like a cutaway. Just give me a piece of it to demonstrate you understand the relationship between the pieces that come together. We got that one? Excellent. Okay? Otherwise you'll be spending forever. Remember, this one's probably, again, a 10 marker. So you can't spend forever on it. You can't spend an hour on this one little piece. One more, drawing design question. It asks you about building design and the information you require to determine what type or form of building you can construct. Basically, if you go back and look at those first couple of slides that talked about what do we need to know before we can build, that's what you need to be answering. Okay, that's almost a give you question. You just got to go and learn what do you need to know to be able to build on a site. Where do you get that information? Who supplies it? What type of information it is? That's it. That's your giveaway question. There's 10 marks. Okay, just do that. So I've got your ball rolling. You've already got a question you need to be able to have an answer for. All right. Now this is probably the most important part. This is my guide to you for after 9 years of doing this. Here's all the things you need to do. Okay. I've set the exam up out of 100 marks, and of course it's worth 40% total, so just worry about it out of 100 marks. Okay? Every mark, if you think about it, our exam is 2 hours and 15 minutes long. There's a 15-minute perusal period. Now, in that perusal period, it's really important, in that perusal period, you are not permitted to write answers. You are not permitted to write answers on the question paper. You are not permitted to write answers in the answer booklet. You are permitted to make notes as to how you will answer the question on scrap paper that is provided to you. It's green scrap paper. That is the only piece of paper you're permitted to make notes on. You understand that? In the first 15 minutes, it's called the perusal period. You are not permitted to answer the questions. You are only permitted to read the questions and formulate how you're going to write those answers and make notes. Okay? Here's the thing. If you start writing or answering a question in the paper during the perusal period, your paper will be removed. You will get a second paper to restart again, but you've lost your momentum. If that happens a second time, your paper is removed and you've deemed to sat the exam and you're out. So, it's critically important for you that you only use that first 15 minutes, then they'll listen to what they tell you. There's a perusal period of 15 minutes. Use that to make notes on your scrap paper. Do not answer the question in your question paper or your answer booklet. Am I absolutely clear on that one? Because every semester it happens. And I don't know how many times I tell you, every semester somebody does it. Okay, so make sure you know, those listening and watching at home, do not write on your question paper or in your answer booklet during the first 15 minutes perusal period. Okay, the instructions will allow you to put your student number on those pieces of paper. You can put your student number. That's it. Okay? So, the exam is out of 100 marks. The reason is it's a 2-hour writing period. 2 hours, 15 minutes. 15 minutes perusal, 2 hours writing. Answers can be written in the 2 hours. So what I say is, 2 hours is 120 minutes. The exam is out of 100 marks. So you only allocate the amount of time for each answer based on the number of marks that's applicable for that question. So if it's a 5-mark question, you spend 5 minutes on it. Okay? And that is it. Because if you do that, come the end, guess what you've got left over? 20 minutes. And I can assure you what will happen in the exam is you will be writing answers. And then you'll move on to the next question. While you'll move on to the next question, your brain will still be processing the previous answers you've given. And you may well go to 2 or 3 questions down and it'll ask something similar, perhaps, to what you previously had to address. And you've gone, oh, I forgot to add that. And you've got time to go back and improve on the other answer. That's what that 20 minutes is for. It's a buffer to give you time to go back or time to change, or if you really want to detail up or trick up a finished question, then do that. So to do that, what I want you to do is every question start on a new page. So when you got question 1, start on page 1. Question 2, start on the next available free page. Leave yourself space at the end of each question if you want to come back and add some more information. Nothing worse than us trying to find question part 3B 5 pages away from where the original one is. Okay? So you've got that extra time. Here are some of my other key tips. Answer the easiest questions first. Give yourself some confidence. Ones you know you can answer, go and answer them. There's no law that says you must answer them in order. So answer however you want. Just answer like question 3, 4, 9, 2, 1, whatever. I don't care. I want to see quality, not the fact that you've had to follow this process. Okay? The other thing that I find a lot of people do is they spend sometimes an excessive amount of time on small mark questions. Okay, that's what the time allocation is about. More often than not, especially in drawing tasks, people are so wound up in trying to get the drawing right that they forget time. They forget that the time's ticking along. And I've seen people working half an hour on a 10-mark question. And that's not good because it just loses all that extra buffer time that you had. Okay? All right. So that's pretty much all I'm going to give you in terms of the exam preparation. I genuinely believe that your assignment 1, your assignment 2, all the work that you've done, and reviewing the sections of the course notes that I've covered, and you've noticed I haven't addressed all the sections. We didn't talk about history of building, so that's not there. We didn't talk about contracts, that's not there. Okay? Only the things that what I've identified here are the areas that I want you to focus in. And that's for the main exam. Remember, if it's the deferred exam, there's maybe a different situation. You may need to look at that area. But you've got more time. You've got a few more weeks. Righto. Here's my own personal advice to you. Okay? My own personal advice is this exam's going to be held at 6:30 at night. Hopefully you're all aware of that. Good. It's in your diary. Good. Okay. Please do not eat a big meal before you go into the exam. Seriously, it puts you off. It'll draw blood away from your brain and put it in your stomach. Because they want to process your food, not give you the brain stress. You know. So just have something light. Have a big meal afterwards. Go and have 6 beers and everything else and celebrate. But do whatever. But don't have a big meal before you go in. Have something and eat something that's not sugary. Okay, there's another tip for you. Don't eat a lot of sugar before you go into the exam. You'll get a sugar rush. You'll get plenty of action for the first hour, and then you'll go into a lull. Okay, so whatever you eat, make sure it's going to carry you through. Okay, because our body rhythms are not sugary. Okay. You are allowed to bring water into the room, but it must be in a clear container. You cannot bring soft drink, you cannot bring coffee, you cannot bring food into the room. So just be aware that you're only allowed, in terms of a liquid form, is water. That's it. You are not permitted to bring any bags in the room. Okay, and as this is a closed book assignment or a closed book exam, you're not allowed to bring any course notes into the room. So therefore, can I recommend, because there's at that time of night limited security around, that anything that you have, like mobile phones and laptops and notepads and electronic devices and things you don't want to lose, don't bring them. Leave them in your car, leave them locked in your room, somewhere else. Okay? Now, mobile phones. We joked about mobile phones, and thank you, I think Neil, was it, who bought me a coffee? Was that you? I don't know, somebody bought me a coffee. We joke about it in the classroom, the phone's going off. A phone going off in the exam is an exit out. So do not bring your mobile phone into the room. Okay? Because that's a very fast track exit out of the building. The other thing that I can give you as a tip, just trying to think of all the positive tips I can offer you, is we will be around to help you during the perusal period. So in the first 15 minutes, if you're reading a question, you're not sure what the question's asking, you're allowed to put your hand up and ask a question. During the exam, you really don't. So during the exam, you're encouraged to make sure that you have the first 15 minutes is there for you to check if there's something you're not sure about. That's when you ask the question. Okay? That's the thing. So during the actual writing time, you should be focused on that. Now, Pretty sure Albert, you'll be there.
I'll go check the date.
Alright. Vinny, you'll be there? Maybe? Yep. You'll have the tutors and me here. We'll all be wandering around the room. Now, there's actually 3 of our construction subjects going to be on that exam time. So there'll be about 5 or 6 of us from our building that will be supervising. Okay? So we'll be checking up on them throughout the process for the next few hours. In terms of, again, drawing equipment, make sure the drawing equipment turns up in a clear plastic bag. You can't bring drawing equipment in those big metal cases with lids and everything else. Last but not least, I may, if you'd see that I've left the room, okay, it's not because I've gone to get a coffee, which I probably wouldn't need one by then, but there is, majority of you will sit in the main auditorium, which is the sports hall. Okay, if you're not familiar with the sports hall is, better go and do that in the next week or so. We also have some students that may need or have applied for either some form of additional assistance time. So in other words, something to do with learning and outcomes or whatever. Okay, it's a medically based request. It has to be proven by a medically diagnosed report. If you're in that ballpark, then you would already know that you're going into a different room. Now that exam generally starts after the main exam, and I still go and visit that room to help those people with any answers to questions. So if I'm out of the room, it's not because I've gone to get a coffee, it's because I'm in another room helping another group of people that are just starting their exam at the same time. Okay? So just be aware if I'm not there. Don't worry if I'm not there and you want to ask me a question, for whatever reason, if Albert, if she's around, or Lynn, if she's around, could answer it for you. If not, just wait till I get back. Okay? Alright. Last thing. Okay? We've given you a pretty comprehensive review of what to study. I've said previously, just a little while ago, I believe you've got everything you need to do in your knowledge bank that you've developed to be able to study hard to answer the exam. Okay? I've given you the structure, and I've given you some very good guide to where you need to go to build your knowledge and revisit that. As a result, from here on, from today on, our help and educational activities come to an end. Okay? This is your time to go and do your own studies. Albert, Lynn and me aren't here to tutor you to an exam result. Okay? This is your time to use your resources that you've developed and you've created over the last 12 weeks to build your base to answer those exam questions. Okay? So please, do not approach us for, can you please answer this question, or can you please tell us the best way to answer this, or can you please tell us how Scott would expect to see that answer look. Okay? Because they're not going to give you that. That's not their job. This is your time for the next 10, 12 days, I think, 12 days. Quiet study. Bring together what you've learned. Start putting your own study notes together. Talk amongst your groups. That's what your teams and your group members are all about. And use them collectively to come up with answers. And if you get the opinion that nobody understands it, at that point I will get involved. If somebody comes to me and says, my group's saying it's this, and I know it's damn wrong, I will tell the group, I'll tell that person, no, that's wrong, you need to look at this. That's it, that's as much help as you're going to get. Do you understand that? Okay, because this is your time to shine. This is your time to put into practice what you've learned through this assessment. Okay, and please don't panic. It's only 2 hours. You'll go through an absolute blink, and if you know your stuff, you'll just blitz it. You'll fly through it. Okay? All right. Well, that's it. So unless there's any questions, yes, Mitchell. Lynn has your model, I think. It's all sitting on the side there. She brought your plans, your model, and your